In this video, I break down the solution for challenge number 14, Gatekeeper 2, the second one, of Ethernaut CTF. And this is part of a series of videos where I break down all the solutions for this Ethernaut CTF. So stay tuned for more. Hello and welcome. My name is Pedro and this is DecentraWise channel. And here we share all things Web3, blockchain development, and security. So if you are into this kind of stuff, you are in the right place. So let's jump right in. This is Ethernaut CTF page, and you can find all the challenges here. We are going to be doing this Gatekeeper 2, okay? If you don't know how to set this up, we have to have MetaMask installed and all this set up. If you have any problems, check our video, or first video in this series where we talk about all those things. Okay, there are some issues that might happen with Ethernaut. We also have other videos explaining how to solve those. So check those out if you have any problems. So the first thing is to open the challenge, Gatekeeper 2, and we also have to open our console so that we can interact with the challenges. And if you have something like this, you are good to go, right? This challenge, let's see what we have here. So it's very similar to the other challenge that we got, the Gatekeeper 1, right? There are 3 gates: Gate 1, Gate 2, and Gate 3. Okay, so in this one we have Gate 1, which is require us to be a contract, right? If message sender is different from transaction origin, this means that the calls to the enter function have to go through a contract. So you can call a contract and that contract call this contract. And that way, message sender is the contract and transaction origin is your wallet, right? So this is the way to pass Gate 1. And Gate 2 is checking the code size and requiring it to be 0. So this one requires us not to be a contract. So this is fun, right? So to go through the first one, we need to be a contract. To go through the second one, we need to not be a contract. This seems impossible, but there is only one situation where this can be achieved, and that is in the constructor of the contract. So this means that whatever things we have to do in this to solve this challenge, we have to do it in the contract constructor, right? And then there is Gate 3, which is a series of hashes of the message sender and blah blah blah. So this is the gate key is possible to calculate if we invert this one. So it's just a matter of inverting the calculation, and based on this, compute the gate key, and that's it. So it's not a very, very hard problem here. So all this we will be able to pass with ease, right? And become the entrant, right? So let's check. We have an instance here. We have this one. If you don't have this instance address, you can get a new instance with this button, okay? And we can check await contract dot entrant. Let's see who is the entrant. It's me already, so let's get a new instance. We need to confirm I have this instance already because I was filming this episode before, but left my microphone disconnected. So just a side point. Okay, we have a new instance. Now let's check instance. It's this one, and the entrant is 0. Now we are good to go. So in order to pass this challenge, we need to become the entrant, right? So let's do that. Let's go to Remix. So we need to develop a contract. So Remix is the way to go. It's easy. And let's create a contract file, new file. This is GATEKEEPER2.sol. There we are. And let's bring the contract codes. Okay, boom. And now let's create our attack contract. GATEKEEPER2 attack. There we are. And now, what do we need to do in this contract? We know that we need to do stuff in a constructor, right? So let's create a constructor. Constructor. We need to somehow receive the address of the victim. Address victim, right? And now we need to do things, right? The first thing that we need to do is we need to compute the gate key, right? So in order to do that, we can do the inversion of that calculation. So we just do this part, the max, and the other part with our address. So, and we get this, right? It's easy. We just move this to the other side and that's it. So this is the easiest part, to get the key, the gate key, right? And so now we can pass this gate key to our enter function. So in order to do that, we need to get the interface, GATEKEEPER2 for our address, victim, right? And call the enter function, right? And this enter function receives gate key. That's it, right? Nothing more. So we just calculate the gate key by inverting our operation, our XOR operation, and we call enter in the constructor. So this will pass gate 1 because it's a contract, right? Gate 2 because it is not deployed yet, so it's deploying, right? So the code size is still 0, and passes gate 3 because it's simple math. It's binary math. So that's it, right? So let's try it out. First of all, let's compile it. It's compiled, okay. And let's deploy our contract, GATEKEEPER2 attack. We need to have our victim contract, which is this one. Let's copy, okay. And now it's just deploy. Deploy with the right victim address, and we're good to go. Approve in MetaMask, and boom. We have our confirmation that we were successful. So let's try that. So let's check if the entrant is different. There we go. We are in, guys. We are in. So this is the way, right? It's very easy. It seems very complicated, but knowing this trick of doing stuff in the constructor, we were past the first 2 gates, and then it's simple math, not a big deal. So we are done. Let's submit the instance to check and confirm in our MetaMask, and there we go. We have completed this challenge, right? So not a big deal here. Hope you enjoyed. And if you learned something in this challenge, go ahead, smash that like button and subscribe for more, because we are sharing videos like this all the time. And hope you enjoyed. Go do that yourself and try this stuff. Okay? Cheers. See you in the next video. Bye-bye.